We'll start this lesson on writing algebraic expressions by going ahead and defining some key terms. So take a few seconds to pause the video and copy down these keywords because they'll be very helpful when we're translating from words into expressions. So pause the video for just a few seconds to copy these and then hit play again when you're ready. So now we're going to translate some words into expressions. So the first example says that a van weighs P pounds. The car is 1,000 pounds lighter than the van. How many pounds does the car weigh? So the keyword here is lighter, and the lighter keyword means that there's going to be a subtraction. So if I'm representing the car's weight, well, the car's weighs P, which is the van's weight, minus 1,000. So that is my answer. Suppose for a second that the van weighed 3,000 pounds. That would be the value of P. So if that were the case, then the car would weigh P minus 1,000, which in this case would be 3,000 minus 1,000. The car's weight would be 2,000. In this next example, we have that a winning lottery ticket is worth X dollars. The payoff amount is to be split equally, and that's a keyword right there, split equally. That means division, remember that from that list of keywords. So be split equally among 3 friends. Write an algebraic expression that represents each person's share of the price. So if the lottery ticket is worth X dollars and it is going to be split equally, that's what division means, into 3 people, then the expression is X divided by 3. Each person receives X divided by 3. Here are some ways to check that. If the lottery ticket is worth $300, that is the value of X. So when we take X divided by 3, that should be $300 divided by 3, which means that each person receives $100. That makes sense. Suppose instead that $1,500 was the value of X. That was the lottery ticket. Well, when we take $1,500 divided by 3, we get that each person receives $500. And again, so that should be making some sense here. In this next example, we have the sale price of a sweater is $20 less than the regular price. They want us to choose a variable to represent one price, then write an expression to represent the other price. So they're giving us a little bit more freedom here. They're not giving us the variable they want us to use. So I am going to choose to represent the regular price using the variable R. So if that's true, then the price of the sweater is the regular price minus $20. Because remember, the sale price of the sweater is $20 less than the regular price. And less is one of those keywords that we learned about. Less than means subtracted by, subtracted from. That is not the only way to write this problem, but it is one way to do it. We'll read the next example, and again, start practicing while you're reading these to look for those keywords that you have learned about. So we know that a plumber wants to cut a 17-foot pipe into 3 sections. The longest section is to be 3 times, that's a keyword, as long as the shortest, and the middle size section is to be 2 feet longer than, that's another keyword, than the shortest. Write an expression for each section of the pipe. So perhaps the easiest thing here, and what I always like to do with these convoluted word problems, is to choose one variable. And it seems to me, and so I call that the independent variable, and it is the one that we know nothing about. We know nothing about it, and furthermore, everything is told to us in terms of that independent variable. So if you look at this example, everything depends on the shortest side, the shortest part of the pipe. So my independent variable is therefore the shortest portion of the pipe, which we're going to call S. That's my independent variable. I can write every other part of the pipe using S. So we already know the shortest is S. Let's talk about the longest side. In the example, they told me that the longest side is to be 3 times as long as the shortest. So the longest side can be expressed as 3 times S, 3 times as long as the shortest. Then they also tell us a little bit about the middle size section. The middle size section, they tell us, is to be 2 feet longer than the shortest. So that would be 2 feet longer than the shortest. That would be 2 more than S. So we have expressions for all three sections. The shortest side is just S. The longest side is 3 times as big as S. And the middle side is 2 feet longer than S. In this last example, again, look for those keywords. We have that on the second day of her trip, Anna drove 300 miles, less than, twice as far as the first day. 300 miles less than, twice as far as the first day. Write an expression for the number of miles she drove each day. So the first thing we need to do is pick a variable, an independent variable. I'm going to call that independent variable the first day's miles. So the first day's miles will be represented using the letter F. So that is how many miles she drove on the first day is F. I don't know the number, that's okay, I can represent it with the variable F. The second day's miles can be represented using the keywords that they're giving us. So on the second day, it says that she drove 300 miles less than twice as far as the first day. So the first day she drove F miles. The second day she drove twice F, but 300 miles less than that. Remember, whenever that keyword less than is used, it actually belongs after the subtraction sign, not in front of. So those are my two expressions.